Why settle for ordinary lessons? Discover a smarter, easier way to learn. This is Muto Online. Get instant access to notes, past papers, and scenario-solved lessons.
I'm here to take you through some applications of oxidation reduction reactions. In the previous videos we made, we looked at the extraction of metals as one of the applications of these kinds of reactions. I'm here to take you through briefly the extraction process of aluminium. I want us to go through briefly this process of extraction of aluminium. Remember, this kind of a question is a question that is set in section B, part 1 of paper 1, chemistry, and we know what they mark. They expect a learner to clearly state the raw materials, which we are going to look at. They expect a learner to state the process of production, the side effects and mitigations of the process of production, and lastly, the social benefits. Remember that. In the process of production, we looked at the things they mark or the award scores too, where we had a look at the vessel, and we said the vessel, it is that container where the process of production takes place. They look at the chemical processes involved. They look at that step where the raw materials are converted to the desired product. They look at the purification stage. If the product formed is in impure state, how is it purified? And lastly, they look at the coherence, the flow of the work. So I'm going to look at these ones. I'm going to generally look at the process of extraction of aluminium. We know aluminium is one of the most useful metals due to its properties. The aluminium has a very low density, so it is a suitable material for making light products, light but strong products, such as the aircraft bodies. The aircraft or the airplanes have to float in the air, so they must be made of light materials. Process of making ships and boats, they need light, strong materials such as this aluminium. We know aluminium has a very good conductivity, heat conductivity, so it is essential for making cooking utensils. We know the aluminium has a high malleability and ductility properties. We know those properties. The ability to be folded and hammered to different shapes. So you can hammer the aluminium to any shape you want, whether flat sheets or any other shape, without breaking. We looked at the properties that make that those metals that way. We looked at the bonding, the metallic bonds, where the ions, the positively charged ions, have the ability of sliding over one another in malleable and ductile materials, but keeping in touch, keeping held by the forces of attraction. So we shall look at that when we get to bonding. We are here to go through the extraction of aluminium and the raw materials for this process of extraction of aluminium are as simple as the ore which is usually bauxite. Bauxite. We need air. I'm going to find that the process of burning of the ore needs air. We use hot air. We shall need concentrated sodium hydroxide solution. This is also an important raw material, very important. We shall as well need pure aluminium hydroxide, small crystals of pure aluminium hydroxide. All these are requirements in this process of production. Members, the process of production is simple. This process takes place in a furnace, and it involves heating the bauxite or the ore in presence of hot air. The role of roasting, shall use this, or heating the ore at very high temperatures, the process we call roasting. The process we call roasting, it is intended at converting iron 2 oxide to iron 3 oxide and removing any traces of water from the ore. So the first step is burning or roasting the ore in presence of hot air, so that we convert any impurities of iron 2 in the ore to iron 3 and to remove any traces of water in it. So this means that we shall have bauxite, this time with iron 3 oxide as the impurity, not iron 2, and free from water. So we've eliminated one of the impurities, which is water. But this one is remaining now. Among the other impurities, we have silica, which we know very well as silicon dioxide. So after roasting it to convert this iron 2 to iron 3 oxide and removing water, we usually go on heat the ore with concentrated sodium hydroxide solution. Heating the ore in concentrated sodium hydroxide solution, it is intended at dissolving the sodium hydroxide will dissolve the aluminium, will actually dissolve the aluminium oxide. We are looking at the components of the ore now. We'll dissolve the aluminium oxide, and this occurs in presence of water to form what we call sodium aluminate. So when we heat the ore, actually we start by grinding it. We grind the ore to fine powder. We grind the ore to fine powder. After grinding it, we heat it with concentrated sodium hydroxide solution. This will form two products. We shall form sodium aluminate and sodium silicate. The iron 3 will not dissolve in the sodium hydroxide, so it will remain as a solid. So this means that the iron 3 at this state will be eliminated because we shall filter it off, remaining with the two things, sodium aluminate and sodium silicate. I think we are moving. So far what we need is the aluminium, not this one. So we still have an impurity. So what we do, we shall have this one, a mixture of sodium aluminate and sodium silicate as our filtrate. We have eliminated the iron 3 oxide. It is out. So the filtrate, to the filtrate we shall add crystals or seeds or small crystals of pure aluminium hydroxide. The purpose of these seeds of pure aluminium hydroxide are to lower the freezing point of the aluminium hydroxide, this aluminium hydroxide here, from this sodium aluminate. So the seeding of this sodium aluminate and the sodium silicate brings about precipitation, of aluminium hydroxide, from the sodium aluminate. So the few seeds of aluminium hydroxide we add will call upon precipitation of more of other aluminium hydroxide crystals forming on them until when all the aluminium is precipitated out. So this means we now have two products. We have a solution of sodium hydroxide, a precipitate of sodium hydroxide, and a clear solution rich in sodium silicate. So the sodium silicate is, the aluminium hydroxide is then filtered off, remaining as the residue on the filtering surface, leaving behind the sodium silicate as a filtrate. So you have also eliminated this impurity. And it is eliminated by seeding the filtrate we obtained after strong heating of finely crushed ore with concentrated sodium hydroxide solution. So the aluminium hydroxide formed is then heated strongly. So we have aluminium hydroxide is heated strongly, and its heating will always result into formation of alumina or aluminium aluminium oxide with water in vapor form. Our target is to get aluminium. So to obtain aluminium free from the other attached elements, this aluminium oxide formed is dissolved in molten cryolite to form The intention of dissolving it in molten cryolite is to lower the melting point of this aluminium oxide. Aluminium oxide has a very high melting point of over 2050 degrees Celsius. It ranges between 2045 degrees Celsius to 2550 degrees Celsius. So it lowers it. And we shall find that after dissolving it in molten cryolite, this aluminium oxide, it is now in the molten state, will need to be electrolyzed in an electrolytic cell at a temperature of 900 degrees Celsius, which temperature is very low compared to this one. And the electrolysis of this formed molten aluminium oxide in molten cryolite, we shall find that it results into formation of aluminium at the cathode. At the cathode, aluminium shall be formed. This process of electrolysis of aluminium, molten aluminium oxide in the cryolite occurs in presence of graphite being used as the electrodes. So the process of extraction of aluminium is as simple as follows. So among the raw materials, we can still include molten cryolite. So the process is as simple. We first of all roast the ore in a furnace so as to convert iron to oxide to iron 3 oxide and to remove any traces of water from the ore. Secondly, we grind the ore that is free from water and containing iron 3 oxide. We grind it to fine powder and then heat it further, this time with concentrated sodium hydroxide solution. Heating it with concentrated sodium hydroxide solution will result into formation of sodium aluminate and sodium silicate as a clear solution, but with solid iron 3 oxide, which will not dissolve in the sodium hydroxide. So the iron 3 oxide will be filtered off and removed from the ore. So that impurity is removed. Further, the filtrate we have, the sodium aluminate and sodium silicate, we seed it with, is seeded with seeds of pure or crystals of pure aluminium hydroxide. Solid aluminium, we are talking of crystals. The addition of these aluminium hydroxide crystals or fine crystals will bring about formation of more of the aluminium hydroxide crystals from this mixture, from this filtrate. The formed crystals are of aluminium hydroxide. They will be filtered off, leaving behind sodium silicate as a filtrate. Since our target is to form aluminium, the aluminium hydroxide formed, or the crystals of aluminium hydroxide formed, are heated further to eliminate any water molecules in it, forming solid aluminium oxide, which sometimes is known as alumina. The formed alumina, or the aluminium oxide, is then further dissolved in molten cryolite, which lowers its melting point from the other big temperature of over 2045 degrees Celsius. And the formed molten aluminium oxide is then electrolyzed in an electrolytic cell using graphite electrodes at a temperature of about 900 degrees Celsius, such that aluminium is formed at the what? The cathode. We talked about it. The formed aluminium is in molten state. So the molten aluminium is then tapped off from the bottom and cooled using water or cold air so as to solidify. And the solidified aluminium is then ready for use. We have a number of side effects of this process of production. Members, you can review the video. You can make a summary of this process of extraction. You can go through, you can pause, forward, rewind so that you can get a good summary of this process of extraction. Or else, this process of extraction has notes that are already uploaded on the platform. On the platform website, the notes are there. You can visit the website. You can download them. So this process of extraction has a number of side effects. Very many. I'm going to talk about a few, but you can put some in the comment section. One, we are seeing we are using a lot of heat with this process of roasting. This kind of roasting results into very high temperatures. This kind of high temperature can cause burns if in contact with bodies of the operators. And the burns results into wounds, we know that, which eventually cause a lot of pain. We shall find that in this process of production, there are waste gases like the sulfur dioxide that are given off, which once in air dissolve in rainwater to form acidic rains. We know the side effects of acidic rains or the impact of acidic rains. We are seeing there is use of water in this process of production during the cooling of the molten aluminium. That kind of hot water, when exposed to the soil, it contains heavy metals. It is containing sodium silicate and other impurities. This kind of impurities alter the pH of the soil, affecting its productivity. So there are a number of side effects which you can as well mitigate. I will not talk much about the social benefits. We know them. The social benefits, like we are hearing, all these processes require employees. So people will get employed. They will be paid money in form of salaries. People will use that money to improve their standards of living. This process of production is involving actually use of other materials. We are looking at the sodium hydroxide. So it will be a source of market for the factories that make sodium hydroxide. And when they buy this sodium hydroxide to use it, they are providing government revenue through taxation. They will tax this sodium hydroxide as it is bought. So the tax the government gets, it is used to develop other infrastructures like the roads. Remember we said this kind of lessons are good because you can pause, rewind, forward. You can even share with your friends. Don't forget to comment or invite others to join us. We are Muto Online. Teacher Alan once again.
Why settle for ordinary lessons? Discover a smarter, easier way to learn. This is Muto Online. Get instant access to notes, past papers, and scenario-solved lessons, all tailored as a competence-based curriculum.
Whether it's UNEB prep or just extra practice, we're here to make learning fun and easy. Subscribe now and let's ace those exams together.